there are four problems. One is on the capacitor. The remaining three are on the electric field and potential due to dipole. Let us see what is the problem on the capacitance. Here, on the basis of the given data of the problem, it is drawn. This is a circular parallel plate capacitor of circular parallel plates, and the radius of the plate, both the plates have same shape and size. The radius of the plate is 5 centimeter. Plate is circular plate, and the distance of separation between the plates is 2 millimeter. That is, D stands for distance of separation. And the potential applied on this capacitor, between these two capacitors, is 200 volt. We are supposed to calculate what is the capacitance of this capacitor and the energy stored up. Energy means the electric energy stored up, the maximum energy which can store up, that is U. These two to be calculated. Now recall this: the capacitance of any capacitor is a function of, the formula says, is a function of these three parameters. That is the area of the capacitor, that is area of the surface which are facing towards each other, that is area of the surface directly proportional, and it is also a function of distance of separation between the plates. It is inversely related to, and also the electrical permittivity of the space between the two plates, that is epsilon naught is the permittivity for the free space, epsilon naught, if it is free space. So this is what the formula for this, the definition, that is general definition for this capacitance of a capacitor. The given data again says that area is not given directly. Instead, it is given the radius of the surface. Either this surface or this, both surfaces are same. This R is the radius of the surface, 5 centimeter. But area, we know that area of any circular surface, area of any circular surface is pi r square. The formula for the area, pi r square. R is the radius of the circular surface. So write this as pi into r square because this is circular surface. And with all this formula, finally we have arrived at this final equation. You have to substitute for them and simplify. We know this epsilon naught in SI unit. The value must be known. It is 8.85 into 10 to the power of minus 12 in SI unit. And value of pi is a constant, 3.142. And the value of r is given in centimeter. We have to convert what is that, write it in SI unit. The centi is there. Centi means 10 to the power of minus 2. So in SI it is meter. 5 into 10 to the power of minus 2 meter. Whole square we have, write it as whole square. In the denominator, D, distance of separation, 2 millimeter. Millimeter is not SI. Write it in SI form. That is, substitute for milli. Milli means 10 to the power of minus 3. That is in meter. Simplify this mathematical equation, then you get this equation. Finally, what is that? We get this value. Just simplify this all exponentials. exponential of 10 and this multiply and divide by this. So we get 3.4774 into 10 to the power of minus 11 farad capacitance. Unit of capacitance is farad. F. So this value we have calculated. Next we shall go for calculation of U. Recall the formula for U. U is equal to half into CV square. It is in terms of capacitance and potential or the voltage between two plates. We have calculated this, given this. Substitute for them and simplify. That is all. Half into, that is 3 point, this is the value we have calculated in SI. This is the value in volt, it is in SI. 200 volt, 200 to the power of whole square is the whole square. Simplify, 1 by 2 is there. We get this value, that is the value 6.9548 into 10 to the power of minus 7 joules. That is energy, unit of energy is joule. J is the SI unit. So look at this, these two values are calculated in the given data. Writing data or drawing any diagram is the first, that is the step of success, what you say. Next, let us move on to the problems on electric field and potential due to dipole. Let me recall the dipole and their axis. Then we go for the problems. So these are the dipoles, that is same dipole. Dipole means the two charges same magnitude but opposite in sign, minus plus. The two charges are separated by a distance 2L, usual notation. Same thing, minus Q plus Q, distance of separation between them is 2L, and this line is called as axial line of the dipole along the axis. This line is called as, here perpendicular to this equatorial line that is passing through the midpoint of the dipole. That is equatorial line, axial line. The point is here along the axis, or the what is that axial line of the dipole. Here the point is here, and in this case I have taken the point here. It is along the what is that equatorial line. Then what is R? R is the distance of separation between the point and the midpoint. Distance of separation between the point and the midpoint. The point is on the axis. Here also R is the distance of separation between the point and the midpoint. That is, here midpoint is this. Now you recall the formula for the electric field at this point and electric field at this point. There is a formula what we derived, or the derivation what we did in the previous class. These are the derivations. Look at this. This is the formula what we derived, that is for the electric field at this point. That is 2 kpr divided by r square minus l square whole square. What is l square? That is half of this whole square. That is EA. EA stands for electric field along the axis, any point along the axis. So that is R and L. This is the equation. So this equation we can use if the values of R and L are comparable. Comparable means the values are closer to each other. Comparable. We can use this equation. Sometimes the R and L are uncomparable. The values, there is a large difference in the values of R and L. That means the value of R is far greater than the value of L. Value of L is very less, value of R is very higher value. Then the same equation is reduced to this type of the form of this one. Same electric field along the axis. It is when the values of R and L are comparable, and this is the values of R when the value of R is far greater than the value of L. This is the equation. Now, if the point is along the equatorial line, the equation derived is what we did in the last class, that is in the previous classes, that is E, electric field due to the point along the equatorial line. This small e stands for equatorial line. That is, equation is Kp divided by R square plus L square to the power of 3 by 2. This is the equation when the values of R and L are comparable. That is the one as you discussed. And the same equation is reduced to this reduced form if the values of R and L are uncomparable. That is, value of R is far greater than the value of L. That is Kp by R cube. These are the equations. Just recall this. And what is the electric potential at this point and this point? Electric potential at this point is always 0. That is, if you take any point, along the equatorial line, potential at any point along the equatorial line is always 0. Any point you take that, this is 1. Already know that. And what is the equation? But here potential at this point is not 0. It has some potential. But the derivation what you get is that is the one. What is V stands for? Potential at this point along the axis. That is Kp divided by R square minus L square. Look at the difference. Equation. So equation is applicable for when R and L are comparable. Here same thing like this. And the same equation reduced to this form, reduced form, that is our Kp by R square. If these are what is that uncomparable, R is greater than L. So along the axis, that is potential along the axis. So remember these equations. While solving the problems, selection of equation. Selection of equation is the success important. What equation is suitable for the problem? That is the one we go for selection. Let me take up the problems one by one. The problem is this. This is drawn on the basis of the data given in the problem. Problem is not written. I'll read the problem. The same thing is. This is a dipole. The charges are 0.2, 0.2. This is minus, this is plus. It is microcoulomb. The distance of separation between the two charges is 10 to the power of minus 8 meter in SI. Now, this data is given, and one more data is given. R is equal to 0.1 meter. That is, you have to calculate what is the electric potential. Sorry, what is the electric field and what is the electric potential along the axis. That is, a point is at a distance of 0.1 meter from the center of dipole. Here like this. R value is given as 0.1 meter. You have to calculate what is the electric field and potential at this point for this problem. And also same problem as one more like this. That is the one along the axis. What is the electric potential and electric field when the point is along the equatorial line like this? Same dipole, same distance along this equatorial, the same distance 0.1 meter from the midpoint. R value is here. So we have both problems. What is that? For this dipole you have to calculate what is the potential at this point, what is the potential at this point. What is the electric field at this point, what is the electric field at this point? Both the problems are there. Now we shall go for the solution. Look at this, first look at the values. Are the values raised Rn value are comparable or uncomparable? 10 to the power of minus 8 meter, that is 2L, of course base by 2 is almost 10 to the power of minus 8, you will divide by 2, something around that. And value of R is 0.1 meter. Here 10 to the power of minus 1, of course. Look at, there is a large difference. That is very high, this is very low. That is, R value is far greater than L. Then for this set of problems, you have to select this is the equation, this is the equation. Equation for along the axis, equation along the equatorial line. Select this equation 2 kp by r cube, that is the point along the axis. Point along the axis. So for all this calculation, we calculate that we require P. What is it? Dipole moment of the dipole. Dipole moment of the dipole is required. Recall what is dipole moment means 2L into Q. 2L means distance of separation of the charges and magnitude of any one of the charge. That is, for this one, 2L is 10 to the power of minus 8 and Q equals 0.2 microcoulomb, convert micro into coulomb, SI. 10 to the power of minus 6 is micro. 0.2 into 10 to the power of minus 6 in SI, it is in SI. Then simplify, you get 2 into 10 to the power of minus 15, here coulomb meter, not centimeter, so it is coulomb meter, dipole moment. Then go for calculation of E and EB and this also whatever voltage. 2 kp by r cube, substitute for them. 2 into value of k, what is k? Coulomb's constant, the value of k in SI is 9 into 10 to the power of 9. And P value is this, what we calculated. Substitute them. And R is, what is that? 0.1. 0.1 means 10 to the power of minus 1, you can take it as 10 to the power of minus 1. Whole cube is a whole cube. Now simplify separately the exponentials of 10 and 10. Get cancelled, 10 to the power of minus 3. And this becomes 36. This into this 36. Here this value 36 into 10 to the power of minus 3 is a numerical value you get. What is that? It is known as electric field. Electric field at this point, that is for this set of data along the axis, that is Newton per coulomb. Newton per coulomb, that is the value. Then in the same, what is that? Let us calculate the what is the potential, electric potential at this point along the axis. Selection is this, kp by r square along the axis. Substitute them. Here value of k, value of p and value of r. Here 10 to the power of minus 1 whole square. Simplify, you get 18 into 10 to the power of minus 4, that is volt. Potential is volt. That is a potential at this point for this set of data along the axis. Let us go for what is the potential at the point at the vertical axis, vertical line. So equation is this. This is the equation you have to select. Kp by r cube. Substitute for them similar to the one we have did it. And r cube is 10 to the power of minus 1, like this. Simplify, you get 18 into 10 to the power of minus 3, that is Newton per coulomb. Force, Newton per coulomb. That is the electric potential. Electric field at this point is this value for this set of data. So what is the potential at this point is 0. Take any point on this, it is 0. Understood? along the equatorial line. That is common for all. So this problem is over. Next, go for the second problem. It is similar, but it is the value are uncomparable. Values of R and L are it is not comparable. They are comparable. The problem is dipole. The dipole is this one. The charge of the dipole is 1 microcoulomb, and the distance of their separation is 4 centimeter. Between this and this is 4 centimeter. And the value of R is 4 centimeter along the axis. That is, point is here. The distance of the point from this point and this point is 4 centimeter along the axis. Calculate what is the electric field and potential. That is similar to this problem. Electric field and potential at this point. Similarly, electric field and potential at this point. If the point is in the equatorial line, the same distance, that is R is equal to 4 centimeter along the equatorial line. What is the equation? Selection of equation. Look at this first. Just see the values and compare their values. Here 4 centimeter, 4 centimeter. This value of R is 4 centimeter, value of L is of course 2 centimeter becomes. So 2 and 4 almost same, it is closer to this. They are comparable. Values of R and L are comparable in this data. In this given data of problem. This is the data of the problem. Problem is not written. The data of the problem is here. So our equation, selection of equation is this. Because this equation you have to select for the axial line, equation for the equatorial line. And before that, do the calculation as usual. P is equal to 2L into Q for this one. 2L, that is 4 centimeter in SI, 4 into 10 to the power of minus 2 meter into Q, that is 1 microcoulomb, that is 10 to the power of minus 6 coulomb in SI. So it becomes 4 into 10 to the power of minus 8 coulomb meter. Like this. Then write the equation. The equation for this one 2 kpr divided by r square minus l square whole square. Substitute for them. That is 2 into value of k in SI, value of p what we calculated, and value of r what is that? Here in SI, that is the one. Here whole square, r square means this whole square, minus of L means 2. That is L, 2L is 4. What is L? 2 divided by 2. 2 into 24 minus 2 in SI, whole square is there, whole square square. Simplify. First simplify this. The term and term, they are common factor. 10 to the power minus 2, common factor. 4 square, 2 square, that is whole square is there, whole square is. Simplify this, and finally we get this. What is this and this? Divide by a 12 square. 12 square means 144. So all 10 exponential 10 is 10 to the power 3 becomes. Simplify, you get 2 into 10 to the power 3 and Newton per coulomb. This is the value you get. Look here, selection of equation is of the important. This is the one. Then substitution, simplification, and taking all of them in SI units. This is the value you get in SI. Similarly, along the axis, voltage is not, potential is not 0, right? What is here? The equation, that is the one we have to use this. That is the one here. Because values are comparable here. Kp by r square minus L, substitute for them. That is K, that is P, that is R, that is L. And simplify, we get this value and then value this. 3 into 10 to the power of 5 volt along the axis. and electric field along the equatorial line. Electric field along the equatorial line. Equation for this is the one need to be selected. square plus L square to the power of 3 by 2. Substitute for them. This is a K value, this is a P value, this is R value, plus this is L value to the power of 3 by 2. Simplify step by step. This becomes 36 into 10, divided into 10. This becomes the numerator, common factor to the power 3 to the power 3 by 2 remains over there. This is over to the power 3 by 2. Again simplify, that is 20 3 by 2, this will go to what is the simplify 36 to the power of 10 to the power of 7, 20 to the power of 3 by 2. First 20 to the power of 3 is 800, 1 by 2 means square of this is this one. Divide by this is gives this value, almost 4. That is electric field at the point along the equatorial line is 10 to the power of 6. This is into Newton per Coulomb. This is one case for this data. And as you know, potential along the equatorial line is 0. Any value give, but this is common for all this. Last problem, look at this problem is, that is a problem, it is drawn on the basis of the data. That is, a diagram is, dipole is this and the distance of separation is 10 to the power of minus 9 meter, and the point is here, the point is neither on the equatorial line nor on the axial line. It is somewhere around, what is that, in the space around the dipole. That is the point. The distance between the point and the midpoint of the dipole is 1 centimeter. That is given. And one more data is mentioned. The line joining the point and the midpoint, that line makes an angle with the dipole axis. That is dipole. There is a dipole is 30 degree. The angle between the dipole and the line joining these 2 points is 30 degree. That is one more data is mentioned. We have to calculate what is the electric field experience at this point and also its direction. Direction of the electric field. What is the direction of the electric field in terms of angle? Again you have to recall the formula what you did, what is derivation. Derivation we did in the last class, previous classes. Look at this. The formula for this kind of problem is this one, is a formula for electric field at any point around the dipole, in the space around the dipole, any point. It is on neither on the equatorial nor on the axis, any point. Kp divided by r cube to the power of square root of Kp divided by r cube into square root of 1 plus 3 cos square theta. What is theta? Angle between this line and this line. Again r value, p value, k value. Given the data. Calculate p as usual, 2L into Q. 2L is 10 to the power of minus 9 meter SI. And the value of Q is 10 to the power of minus 6 Coulomb. Simplify 10 to the power of minus 15, that is Coulomb meter. P value. Then calculate E in the equation. Substitute, write the value of K, value of P 10 to the power of minus 15 into square root of 1 plus 3 cos square 30. Theta is 30 degree. And R cube is, what is R? R is 10 to the power of, that is R is 1 centimeter. 1 centimeter is 10 to the power of minus 2 meter. Whole cube is the whole cube. Then simplify. First simplify this, all of them will cancel here. All exponential can have this, only 9 remains here. And go into the square root, 1 plus 3 is there. What is cos 30? Cos 30 is root 3 by 2 whole square. Because cos square means whole square. So 9 into here root 3 whole square, 3 into 3, that is becomes 3. 3 into 3 divided by 4. 13 by 4. Take the square root and 9, simplify, you get 16.225 the value. E value you get 16.225 here Newton per coulomb. This is the value you get. That is called, this value is called electric field at this point. Magnitude of electric field at this point is 16.225 Newton per coulomb. Equation used is very important. This is the equation, remember the equation. Equation for a point, any point around the dipole like this. Finally, what is the direction of the electric field with respect to this line? That is not the same direction, 30 degree. So for the direction, again we have the formula, we call the formula theta plus for the direction theta plus tan inverse of tan theta by 2. Theta plus tan inverse of tan theta by 2. Substitute for theta is known. Here theta is 30 degree plus tan inverse of tan 30 by 2. Tan 30 value is 1 by root 3 divided by 2. This same thing. Simplify this, you get 0.2886. 0.2886. Here tan inverse of this, find out from the table, it becomes 16, it is 16.1. 30 plus that is 46.1 degree. That is the angle of direction with respect to this line is, that is 46 is more than this angle. 46.1 resultant, that is resultant electric field. It is deviate more from this angle. 46.1 is the angle shows the direction of the electric field with respect to this. It is the magnitude of this value. Look at this, all the types of problems are covered. So here the problems on the axial line, the problems on the equatorial line, both electric field and electric potential, and the problem on like this, any point around the dipole moment like this. Only thing we need to remember the standard equations and their selection, very important. Thank you.